Welcome to my video on how to write polynomials when given their roots. On my last video we did some factoring in a similar situation, but in this one we're going to write the polynomial function. So as we go along here, we need to definitely keep in mind the connection between factors and roots, and we also want to take a look at some tricks later on when we're given irrational or complex roots. So first and foremost, in this case we are given 3 zeros. Another word for zero is a root or a solution. And the connection between solutions and factors, or roots and factors, or zeros and factors, is pretty simple. X minus -4 is a factor if -4 is a root. X minus -3 is a factor if -3 is a root. X minus 2 is a factor if +2 is a root. So if we simplify these are the factors that will create our function. And these 3 roots will, when entered into this function, give you a value of 0. In other words, f of -4 is 0, f of -3 is also 0, and f of 2 is 0. On a graph, these will be where the graph crosses the x-axis. So all we need to do is write the polynomial of least degree with integral coefficients that has these zeros. So I'm simply going to take these factors right here and multiply them out. It's as simple as that. So let's take 2 at a time. We'll FOIL these together. So x squared plus 7x plus 12 is what we get there, and we FOIL. Bring this guy down, and we're simply going to have to distribute this binomial into all 3 of these terms. So FOIL is a distributive, and this is obviously another distributive, so this is kind of like a double distributive problem. So x to the 3rd minus 2x squared plus 7x squared minus 14x plus 12x minus 24. Simplify. X cubed minus or plus 5x squared minus 2x minus 24. This is our function. And just to confirm that these indeed are the zeros, I'm not going to check all of them because this might be a long video, but let's just check +2. So if I put 2 in here, I should get 0 as my answer. So this is 8 plus 20 minus 4 minus 24. So this is 28 minus 4 minus 24. 24 minus 24 is 0. Cool. So on a graph, if you were to graph this thing, right, -4 is over here, 1, 2, 3, 4. So there's one of my, let me put it in red. There's one of my zeros. -3 is also a 0, and +2 is a 0. This has, let's see, a cubic. It's a positive lead coefficient, so the end behavior I know is going to go up on the right and down on the left, so this function is going to look something along these lines. A little tricky to draw, but something like that. And you can confirm that with your graphing calculators. It's not going to be perfect, right, because I'm not sure exactly what the maxes, the extrema are and stuff, max and mins, but that's the general shape of this thing. Cool. Moving on. That was the easy one. Number 2 is a little bit trickier. Remember, these are roots or zeros, and when we have these irrational roots, they have partners. they're partners, if positive radical 3 is a root, the negative radical 3 is also a root. If these two go together, so you keep the number out in front and you change this number right here. So those are, conjugates, they're partners. And let's make a little list. If this is a root, then the connection is really important between roots and factors. X minus negative root 3, so I'll just write positive root 3. Negative 3 plus root 7, x minus that. Simplify, x plus 3 minus root 7. If negative 3 minus root 7 is a root, x minus that is a factor. And I'll simplify. Alright, so I've got factors here, 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 and here. Let me use different colors for these. The green ones are paired together, and the gray ones are paired together. So now let's just multiply our factors. X minus root 3, x plus root 3. Multiply these two together. We're going to FOIL. First times first. Outside, inside, and last. Negative square root of 3 times positive square root of 3 is just negative 3. The middle terms cancel out, so we're left with x squared minus 3. Over here, the gray ones, x plus 3 minus root 7, x plus 3 plus root 7. Multiply, we're doing the triple distributive here. So the x is going into 1, 2, 3 terms. So here we go. X squared plus 3x plus x root 7. The positive 3 is going into these 3 terms. So it's positive 3x, positive 9, positive 3 root 7. And finally, negative 7 is going into all 3 terms as well. So negative x root 7, negative 3 root 7, and just negative 7. Looks pretty confusing, but check this out. That and that cancel. That and that cancel. Leaving us with x squared. So we have this, and these are multiplied together. X squared plus 6x. So these combine. 9 minus 7 is 2. So there you go. That is what we get when we take these two, multiply them together, and these two, multiply them together. Well, guess what? We need to multiply those two together. So again, here we go. This guy is going to multiply by these 3 things. It's kind of like a triple distributive, if you will. So let's go a little faster here. X to the 4th minus 3x squared plus 6x cubed minus 18x plus 2x squared minus 6. Combine like terms. Cube term comes next. Minus x squared minus 18x minus 6. So that is my function. Now again, just to kind of, if you wanted to check, you certainly can. I'm not going to, but if you checked, all 4 of these would give you a value of 0. But that's your answer. So I'll highlight that and move on to the next one. The last one is complex roots. So these are our roots. If I is a root, negative I is a root. If negative 3 plus I is a root, negative 3 minus 3i is a root. So let's make a connection here between roots and factors again. So let's list our root I. So our factor is x minus I. If our root is negative I, this is x plus I. Negative 3 plus 3i x plus 3 minus 3i. Negative 3 minus 3i, x plus 3 plus 3i. So the connection is x minus the root every time. And again, these are partners and these are partners. So let's multiply them together. X minus I, x plus I. Plus xi minus xi minus I squared. Now the middle terms cancel. Positive xi minus xi, they cancel. Negative I squared is actually a negative 1. Remember, I squared equals negative 1. So negative 1 is positive 1. So there we go. That's what we get when we multiply the greens together. The grays are a little bit more complicated. X plus 3 minus 3i. X plus 3 plus 3i. So let's multiply these two together, and then we'll just throw it down here, and we'll be finished. Well, we'll multiply a little bit more, but we'll be almost finished. So here we go. X, go a little bit faster, squared plus 3x plus 3xi. What I'm doing here, taking this, multiplying it by all three of those. Then I'm taking this, multiplying it by all three of those, taking this, multiplying it by all three of those. So we have plus 3x plus 9 plus 9i, negative 3xi minus 9i minus 9i squared. Looks like a mess, but it's not too bad. The positive 3xi and the negative 3xi cancel. The positive 9i and the negative 9i cancel. Negative 9, remember I squared is negative 1, so that's actually a plus 9 over there at the end. So we have x squared plus 6x, 3x and 3x is 6, and then 9 and 9 is 18. 9 plus 9 is 18. And let's just multiply these two things out together now. So again, this times this, this times this, and this times this. Kind of a triple distributive. So x to the fourth plus x squared plus 6x cubed plus 6x plus 18x squared plus 18. I think I got that right. Let me check again. I feel like I messed that up. X to the fourth, x squared, 6x cubed, 6x, and then 18x squared and 18. Yeah, that's fine. So let's just simplify it. So this is our function. X to the fourth plus 6x cubed plus 19x squared plus 6x plus 18. So if you were to take these roots, any of these roots, and plug them back into the original function, you should get 0. Let's, just for fun, let's try to evaluate this function for I. So I to the fourth plus 6i to the third plus 19i squared plus 6i plus 18. So this should be 0. Let's see if it is. If it's not, then I guess I did something wrong. But I to the fourth, well, if I remember, I to the 0 is 1. I to the first is I to the second is negative 1. I to the third is negative I. And then it keeps repeating. I to the fourth is back to the original. And so on and so forth, right? This is kind of like a modular arithmetic. There are 4 units in the cycle. And everything else just kind of follows that pattern. I1, I, negative 1, negative I, and so on and so forth. So I to the fourth I know is 1. I to the third is negative I. I see that right there. So this is plus 6 times negative I plus 19. I squared is negative 1 plus 6i plus 18. Negative 1 minus 6i minus 19 plus 6i plus 18. Negative 1, oh, check this out, this works. Negative 6i and positive 6i cancel. So I have -1 minus 19 plus 18. So this is -20 plus 18, which is -2. Oh boy, I screwed something up here. And I figured it out. I made a very silly mistake right here. I put a negative there for some reason, and that'll do it. So now I've got the reds cancel out. 1 minus 19 plus 18. That's -18 plus 18, which is 0. Great. That took me a few seconds. I had to pause the video and figure out where the heck I made my mistake, but I found it. Thank goodness I didn't make any mistakes. So, but that just goes to show you, you know, sometimes you make one little mistake and that just causes you to sort of go back and check your work and slow down a little bit. But anyway, 3 examples there on how to write equations, polynomial equations, when given roots or zeros. So hope you enjoyed it, and I'll look forward to, I think the next couple videos I think I'm going to do are all about logarithms. I think it'll be a 3-part video series, so look forward to that. Thanks for watching.